Quadratic equations refers to the equations of the form y equals to ax squared plus bx plus c, where a, b, and c are all numbers. And the term quadratic refers to the fact that the highest power in this particular equation is squared. So, and if you plot this particular equation, it will form a parabola. Assume a is positive, then we have parabola that's facing up. And if this parabola cuts the x-axis, then it will look something like this. Well, sometimes the parabola may not cut the x-axis at all, or only touches the x-axis at one place. But if it touches two places, then these 2 points will have the y value of 0 because they are on the x-axis. So 0 equals to ax squared plus bx plus c. In this case, if we can find the solutions to this particular equation, we'll know where these 2 points are, where the parabola cuts the x-axis. So let's try an example. Let's have a simple one. 0 equal to x squared plus 2x. So in this rather simple example, as you can see, y is 0, so we're looking for something on the x-axis. And the coefficient of x squared of the first term is 1. So in this particular case, a is 1. And b is 2. And c is 0. So that's a very simple form. Now, we just have to factorize this. The highest factor between x squared and 2x is obviously x. So we can pull it to the front of the parentheses. And we end up with x plus 2. So now we'll have to find the values for x, which this equation will hold. So either x has to be 0, or x plus 2 has to be 0. In the second case, x is obviously negative 2, because negative 2 plus 2 gives us 0. What does this mean? It means that if we have the axes and have a parabola, the first point where the parabola cuts the x-axis is where x equals to 0, 0 here, and where x equals to minus 2 here. So we end up with a parabola that looks like this. Well, it needs to be touching. So this is the first case. 2 solutions, 2 points of where the parabola cuts the x-axis. Now let's have another example, a more special one. Let's have a 0 equals to x squared plus 4x plus 4. If you're familiar with your quadratic trinomials, you will realize that this is in fact a perfect square. So we have x squared plus 2 times 2x plus 2 squared, which means it can be factorized into the form of 0 equal to x plus 2 squared. In this particular case, we can see that there is only one possible solution for x, which is x equals to negative 2. That's the only possible solution. What this means is that when we draw the parabola, we have a negative 2 here, and the parabola only touches the x-axis at this one point. Now, let's have something that's even more complicated and much more prevalent than these 2 examples. Let's say we have some number some natural number as the coefficient of x term and some other number as the constant. We can have, say, 0 equals to x squared plus 4x plus 3. In this case, the thing we should do is to first factorize it. So we end up with x something and then x something else. We're looking for two terms here. For quadratic trinomial, we're factorizing it, looking for two terms here. If you multiply them two together, they should give you 3. And if you add them together, they should give you 4, positive 4. So there are only two possible numbers here, positive 3 and positive 1. So we put them down. As you can see, because 3 times 1 is 3, 3 plus 1 is 4. So that's our factorized form. Now we're looking for solutions. X plus 3 times x plus 1 has to be 0. So either x plus 3 has to be 0 or x plus 1 has to be 0. What does that mean? It means that x, in the first case, x has to be negative 3 because negative 3 plus 3 is 0. And in the second case, x has to be negative 1 because negative 1 plus 1 is 0 as well. What does that mean in terms of parabola? Well, we can have a parabola. It means that the first intercept is x equals to minus 1. So correction, minus 1. And the second intercept is x equals to minus 3. And we end up with something that looks like this, with two intercepts. Of course, arrows to show that they go on forever. Let's try another example. Say x squared minus 7x plus 10 equals to 0. Notice that where the 0 is makes no difference to the equation in the end. So x with something times x with something else has to be 0. In this case, we're looking for two numbers. When you multiply them, they have to give you 10. And when you add them together, they have to give you negative 7. Obviously, the two numbers are negative 5 and the negative 2. Because negative 5 times negative 5 times negative 2 is 10. And negative 5 plus negative 2 gives you negative 7. So once again, we list the two solutions. Either x minus 5 equals to 0 or x minus 2 has to be 0. So the only possible solution for the first one is x equals to 5 because 5 minus 5 is 0. And the second one, x has to be 2 because 2 minus 2 is once again 0. So if we have, once again, let's have a parabola. It means that at two places, x equals to 2 and x equals to 5, we have our parabola cutting the x-axis. So let's have something more complicated. As you can see here, the coefficients of x squared so far has all been 1. Now we have something larger than 1 for the coefficient of x squared. Let's have a look at this one. 2x squared plus 9x plus 4 equal to 0. So this form complicates things slightly because we will have x, something with x, and something else, and then something else with x, and something else equals to 0. Because here we have to have terms in front of x whose product has to be 2. So this thing in front of x times this thing in front of x has to be 2. And then this thing times this thing here has to be 4. And to complicate things even further, this thing here times this thing plus this thing times this thing has to equal to 9. To solve this, we have to resort to the cross method, where we break down this term and this term into their factors and we manipulate them until we get the middle term. It's unfortunately a trial and error process that sometimes you have to make more than one attempt. So let's have, say, 2 factors of the first term. Let's have 2 and 1, since that's the only 2 possible factors of x. And then we cross them, because this times this and plus this times this has to be 9. So next part we have the 2 factors of 4. Unfortunately, we have to go through trial and error. Let's have 2 factors of 4 being 2 and 2. 2 times 2 equals to 4. 1 times 2 equals to 2. Unfortunately, there is no way we can make these 2. Nothing we can do to make these 2 equal to 9. So obviously, that's not the correct breakdown. Let's try something else. Once again, 2, 1, cross. This time, let's try 1 and 4. 2 times 4 is 8. 1 times 1 is 1. Unfortunately, we have 1 plus 8 equals to 9, which is what we want. So we can just, of course, they have to be positive, because these 2 multiplied has to be positive 4. And we just transcribe this and this with 2x plus 1 and 1x plus 4. Of course, in a lot of cases, you can just leave the 1 out, and it just automatically assumes it's 1x. This is our solution. This is our factorized form. And now for the solution, either 2x plus 1 has to be 0, or x plus 4 has to be 0. Notice that if you can't see the answer straight away, you can just tell that this is just another small algebraic equation with 2x plus 1 equals to 0. We subtract 1 from both sides, we have 2x equals to minus 1. And then we divide both sides by 2, and x equals to negative a half. So in the first case, x equals to negative a half. And second case, x equals to negative 4. And that's our 2 solutions. So if we plot this thing again in the form of parabola, x equals to negative a half and x equal to 4, negative 4, and we end up with something that looks like this. Next example, let's have x. Let's have something slightly more complicated. 6x squared plus x minus 12 equals to 0. So once again, we're looking for something with x, something else, and something else with x, and something else. So once again, these two terms multiply, this term and this term, we multiply them, they have to give you 6. And this term and this term, we multiply them, they have to give you negative 12. And when this term multiplied by this term and this term multiplied by this term, and you add them together, they should give you positive 1. Okay, so we'll break the thing down. 6 can be broken down into 2 and 3, 2 factors of 6. Cross, of course, you probably won't get the solution in the first go sometimes, but for demonstration purposes, I already know the answer is 3 and 4, and 4 has to be positive and 4 has to be negative, because negative 4 times 3 gives you negative 12. 2 times negative 4 gives you negative 8. 3 times 3 gives you positive 9. And when you add them together, they give you positive 1. So the coefficients of x here will be 2 and 3. So 2 and 3. The two terms here will be positive 3 and negative 4. And that gives us 2 possible answers. We end up with 2x plus 3 equals to 0, or 3x minus 4 equals to 0. To solve them, very basic algebra. 2x plus 3 equals to 0. We subtract 3 from both sides. We have 2x equals to minus 3. We divide both sides by 2. X equals to negative 3 over 2. And the second one, x, well, 3x minus 4 equals to 0. We plus 4 to both sides. We have 3x equals to 4. And we divide both sides by 3. And x equals to 4 over 3. So this is our 2 possible solutions. In the first case, x equals to minus 3 over 2. And second case, x equals to 4 over 3. And here is the answer.